Have you ever noticed something a little, well, frustrating about the AI models we use every day?
Oh, definitely.
Like ChatGPT, Claude, all those assistants. They're amazing at writing things, answering questions, sure, but...
But they forget things.
Exactly. Even in one conversation, they can lose the thread, forget what you like, or, give you info that's just plain old. It's like they've got this really short-term memory.
Yeah, goldfish memory sometimes.
Right. Think about your computer, though.
Yeah.
It remembers what you did yesterday, right? Your settings, your files. So why can't these super advanced AIs do the same?
That's the million-dollar question, isn't it?
Well, this deep dive is all about a potentially revolutionary idea aiming to fix just that. It's called MemO, a memory operating system for AI.
Interesting name.
Yeah, and we're going to explore how MemOS tries to fundamentally change how these large language models, these LLMs, manage, keep, and even evolve knowledge, basically tackling those frustrating memory gaps.
So giving AI a real memory.
Think of it as maybe a shortcut to understanding how we might give AI a truly persistent memory, one that learns and grows, kind of like ours.
And what's really fascinating here, I think, is that we're moving beyond just, throwing more data at the problem or building bigger and bigger models.
Right.
This is about thinking differently, thinking about how AI actually manages its own, let's call them cognitive resources, a bit like how our brains decide what's important to remember and how to store it.
Okay. And where are we getting this information today?
Our insights are coming from a pretty cutting-edge research paper. It's titled MemOS, a memory OS for AI system. It's got a big team behind it from MenTensor and several top universities.
So this isn't just theory then?
No, not at all. It's a deep look into the actual technical plumbing, the backbone of how AI memory could really evolve.
Okay, let's dig into the core problem then.
Yeah.
What is it about today's, incredibly powerful LLMs that makes them so darn forgetful?
Well, fundamentally, today's LLMs rely mostly on two things. First, their static parameters, that's like their fixed knowledge base baked in during training.
The stuff they learned initially.
Exactly. And second, these very short-lived contextual states, you can think of that like a scratch pad.
Okay.
But it gets wiped clean really quickly, often just after one turn in a conversation or maybe a limited number of words, tokens.
So that's the bottleneck.
It's a huge bottleneck. This limitation really restricts their ability to handle long conversations, to personalize continuously, or even just maintain consistent knowledge over time.
And what about things like RAG, Retrieval-Augmented Generation? I thought that helped with bringing in new info.
It does help, yeah. RAG tools pull in external information, which is great for getting up-to-date facts, but they're often stateless.
Stateless, meaning?
Meaning they fetch the information on the fly, but they don't truly integrate it into a persistent, evolving memory. They don't learn from it, not really. It's more of a workaround, a clever patch, not a fundamental solution to the memory problem itself.
So it's like RAG is constantly looking things up on Wikipedia for the AI.
Yeah, exactly.
But the AI never actually learns this stuff or even remembers that it looked it up 5 minutes ago.
That's a perfect analogy. It doesn't build lasting knowledge from those lookups.
Okay, so what's a real-world example where this lack of memory becomes really, annoying for someone using it?
Well, the biggest headache it causes is just a lack of real continuity. Imagine you're working on a complex project, maybe collaborating with an AI assistant over several days.
Okay.
You tell it specific things like your preferred writing style, or you give it historical data for a particular client. But then each time you start a new session, or sometimes even halfway through a long one,
It forgets.
It might revert to its default behavior or ask for information you've already given it. It's incredibly inefficient, and it really breaks the illusion of talking to something truly intelligent.
Yeah, that sounds frustrating.
And this amnesia, as you called it, leads to basically 4 major challenges for current LLMs.
Okay, what's the first one?
The first is long-range dependency modeling. Basically, LLMs struggle to keep track of instructions or maintain consistency over long tasks or dialogues.
Because of that limited scratchpad, the context window.
Precisely. That context window is physically limited, so the AI ends up forgetting past instructions or just snapping back to its default mode. Imagine using an AI for a complex coding project.
Right.
You define some specific architectural patterns early on, and then later, the AI just completely forgets them and starts doing something different. It highlights this critical need for what researchers are starting to call infinite context.
Infinite context.
Yeah.
The ability to remember everything relevant forever, basically.
Essentially, yes. or at least for as long as it's needed for the task.
That makes perfect sense. It's like trying to have a deep conversation with someone who keeps, well, losing their train of thought completely. What's the next big hurdle?
The second major challenge is adapting to knowledge evolution. The real world changes constantly.
All the time. New laws, new discoveries, market shifts.
Exactly. But the static parameters of an LLM, that baked-in knowledge, it just can't keep up.
So it becomes outdated.
Very quickly. And while REG helps by fetching current data, as we said, it's just a patch, it can actually end up citing old and new information, say outdated and current regulations, side by side without realizing they conflict.
Oh, wow. So it wouldn't know how to reconcile them.
Nope. It can't really track how knowledge evolves or figure out which facts are now obsolete. You could genuinely end up with an AI confidently giving you contradictory advice based on different points in time.
Yikes. That could be genuinely problematic, depending on the task.
Absolutely. Which brings us to the third challenge, personalization and multi-role support.
Making the AI feel like it actually knows you.
Right. Current LLMs lack what the paper calls durable memory traces. Every new chat session is basically a blank slate.
You have to start from scratch every time.
Pretty much. You have to re-explain who you are, what you prefer. Even the commercial tools like ChatGPT that do offer some memory features, they're often quite limited.
Yeah.
Well, they run into things like capacity limits, how much they can remember. The updates to that memory can be pretty opaque. You don't always know what it's learned or why, and you usually can't directly edit or control that memory easily. It's more about passive recording than structured, controllable recall.
So it's not enough for true personalization or for an AI to maybe act differently if I need it to be, say, a professional assistant versus a casual chat buddy.
Exactly. It struggles to maintain those distinct roles or preferences over time.
Okay, and what's the final piece connecting all this? You mentioned 4 challenges.
The fourth one really ties it together: cross-platform memory migration and ecosystem diversity.
Okay, what does that mean?
It means that today, AI memories are often trapped in memory islands.
Islands.
Yeah, isolated silos. So imagine you spend ages exploring an idea, building context with an AI like ChatGPT.
Okay.
Then you switch to a different AI tool, maybe something specialized like Cursor for coding. Can that context just move with you?
Probably not easily, I'm guessing.
Almost certainly not. You're forced to rebuild that entire context from scratch in the new tool. This really hampers continuity and stops you from reusing knowledge across different AI environments.
It creates friction.
Huge friction.
Yeah.
And it raises a really important question. If our AI can't remember its interactions and learning seamlessly across all the tools and platforms we use, how can it ever become a truly persistent, collaborative partner in our lives?
It's more than just annoying that it's a fundamental block to deeper intelligence.
Exactly. It's not just about efficiency. It's about enabling a foundational leap in what AI can do for us.
Wow. Okay. Those challenges paint a pretty clear picture of just how limited AI memory is right now. Really sounds like we need a completely different way of thinking about how AI handles information. So what's the big idea here? What's the proposed solution?
This is where MemOS comes into the picture. The core idea, the really fundamental shift, is to stop treating memory as just some hidden internal detail of the AI model. Instead, MemOS proposes treating memory as a first-class, manageable system resource, just like how your computer's operating system manages the CPU or the RAM.
Okay, so memory becomes something the system actively controls and allocates.
Precisely. MemOS provides a unified framework for organizing all kinds of memory, for maintaining the AI's internal state over time, and crucially, for supporting long-term adaptation and learning.
It really is like an operating system, but for the AI's brain.
That's the concept.
That's a profound shift.
Yeah.
And to actually make this work, MemOS offers 3 core capabilities, is that right?
That's right. 3 key pillars. First up is controllability.
Control over the memory.
Full control. MemOS gives you complete lifecycle management over individual memory units. You can control their creation, when they're activated, how they might be merged or fused with other memories, and even when they're disposed of.
So you can delete old memories.
Yes, or set them to expire. It includes multi-level permission controls, who gets to see or change what, and context-aware activation, making sure the right memory is used at the right time. It also ensures safety and traceability.
Can you give an example of that?
Sure.
Yeah.
Let's say you tell an AI your dietary preferences because you want a recipe. With MemOS, you could set that specific memory chunk, your preferences, to automatically expire after, say, a week.
Ah, so it doesn't just hang around forever.
Exactly. It ensures privacy, but also keeps the information relevant for future tasks. Maybe your preferences change next month.
Okay, so it's not just about remembering everything, but remembering the right things securely and for the right amount of time. That sounds crucial, especially for privacy. What's the second capability?
The second pillar is plasticity.
Plasticity.
Like flexible.
Exactly. This is about MemOS's ability to support memory restructuring and migration across different tasks and roles. Memories aren't just static blobs of data. How does that work?
They can be sliced up, tagged with metadata, organized into hierarchies, like a well-structured file system. This allows the AI to activate different memory views depending on the context.
Memory views?
Yeah. Imagine the AI needs to switch from being your casual assistant planning a weekend trip to being a professional aide helping you draft a legal document.
Very different roles.
Totally different. MemOS would allow it to dynamically load and organize the relevant memory sets for each role, maybe bringing up past travel plans for the first and legal terminology or case notes for the second. It makes the AI much more nuanced and adaptive.
That is a huge step towards AI that can genuinely wear different hats, so to speak. Okay, controllability, plasticity. What's the third crucial capability?
The third one is evolvability. This is maybe the most forward-looking one.
Evolvability. The memory can change over time.
Not just the content, but the type of memory itself. MemOS enables dynamic transitions between fundamentally different kinds of memory storage within the AI system.
What different kinds are there?
Well, you've got the parameter memory. That's the deep, fixed knowledge that's embedded in the model's core weights during training. It's hard to change.
Right, the base knowledge.
Then there's activation memory. This is the temporary contextual state during inference. You could think of it as the AI's real-time working memory or thought process. Very fast, but short-lived.
The scratch pad we talked about earlier.
Sort of, yeah, but potentially managed more effectively. And finally, you have plain text memory. This is for explicit, structured knowledge fragments like notes the AI has taken, facts it's been given, user preferences, things like that, stored externally, maybe in a database.
Okay, parameter, activation, plain text. How does evolvability connect them?
This is the cool part. MemOS can actively convert memory between these types based on how it's used. For example, if you define a rule in a conversation, always use formal language with this client. MemOS could take that plain text instruction and convert it into active memory for immediate use.
So it acts on it right away?
Yes. Or, even more interestingly, if a piece of structured knowledge from the plain text memory is used very frequently and proves stable, MemOS could decide to compress or distill it into the model's more efficient parametric form.
So it actually becomes part of the AI's core knowledge. It learns it deeply.
Exactly. It's like consolidating learned facts into long-term memory. This concept of evolvability means the AI isn't just deciding what to remember, but actively optimizing how it remembers it, transforming information for the most efficient and effective use. It's truly learning from experience in a dynamic way.
That's fascinating. It's like its own internal knowledge management and curation system, constantly optimizing itself. Okay, now you mentioned earlier that MemOS uses a unified framework. At the heart of this, abstracting all these different memory types is something called the Mem Cube. Can you break that down for us? What is a Mem Cube?
Absolutely. The Mem Cube is really the cornerstone of MemOS's unified memory management. Think of it as a standardized universal container, a box, if you like.
A box for memory.
A box for any type of memory within the MemOS system. It doesn't matter if it's a piece of factual knowledge, a temporary thought process from the activation memory, or even a tweak to the AI's core behavior or user preferences. It all gets packaged up neatly inside a MemCube.
One standard format for everything.
Exactly. And each MemCube has two main parts. First, the memory payload, that's the actual content, the memory itself.
The data.
The data, yes. And second, crucially, is the metadata. This is information about the content, data about the data.
Okay, so the metadata isn't just like a label. It does more.
Oh, much more. The metadata is absolutely vital for MemOS scheduling and governance functions. It gives MemOS the intelligence it needs to manage each piece of memory effectively.
How is it structured?
It's categorized into three main groups in the paper. First, you have descriptive identifiers.
Okay, like what?
Things like a timestamp, when was this memory created or last updated? An origin signature, where did it come from? Was it from the user, an external database, maybe from the AI's own fine-tuning process? And a semantic type. What kind of information is this? Is it a task prompt, a factual statement, a user preference, a piece of code?
Got it. So it's like a very detailed fingerprint for every single memory unit. That makes sense for tracking.
It is very precise. The second category is governance attributes. This is all about control and rules.
The security and management side.
Exactly. This includes things like access control, who has permission to read this memory, who can write to it, can it be shared. It also includes a lifespan policy.
Like the auto-delete you mentioned.
Precisely. How long should this memory stick around? It could have a time-to-live setting. It also includes a priority level, which helps the Mem scheduler decide what's most important right now, and compliance and traceability tags, maybe marking data as sensitive, or adding watermarks to track its origin if it's shared or outputted.
Wow, that's really treating memory like a highly managed, secure corporate asset with clear rules. Okay, descriptive governance. What's the third group of metadata?
The third group is behavioral usage indicators. This is where MemOS tracks how the memory is actually being used.
Like how often you access it.
Exactly. How frequently has it been accessed? How recently? This helps MemOS understand if a particular memcube represents hot memory needed often and quickly, or cold memory, rarely used and maybe suitable for archiving.
Okay, and this usage tracking ties into that evolvability idea, right? This is the aha moment.
This is the big aha moment. Based on these usage patterns, MemOS can dynamically change a memory's type. That cross-modality memory transformation we talked about.
Right, so give me that example again.
Okay, so if a piece of plaintext memory, like a common user command or preference, gets used constantly, MemOS might say, okay, this is important and needed fast.
So it promotes it.
It transforms it into activation memory, making it readily available in that fast, temporary state for almost instant processing next time.
Cool. And the other way.
If stable, reusable patterns or facts emerge from interactions and prove consistently useful over time, MemOS could decide to distill them into parameter memory.
Baking it into the core model.
Baking it into the core model's knowledge, making it deeply learned. And conversely, if some part of the core parameter memory becomes outdated or isn't used much anymore,
it can demote it.
It can offload it, maybe back to external plaintext memory where it's more flexible, can be reviewed, or eventually archived properly.
So a memcube isn't just a static container at all. It's a living, breathing, adaptable unit of memory that can fundamentally change its form and status depending on how useful it is at any given moment. That's really quite wild when you think about it.
It is. And think about what that really implies. The AI isn't just passively storing facts anymore. It's very knowledge-based. Its memory system is actively learning and optimizing itself.
Optimizing how it remembers.
Exactly. Becoming more efficient, more intelligent over time. It's much more like how our own brains seem to work, prioritizing important stuff, consolidating memories, letting other things fade. It makes memory a self-regulating, self-evolving resource. That's a massive leap forward.
That dynamic nature feels incredibly powerful. Okay, let's try to visualize how this whole system actually fits together and works. The paper mentions MemOS has a modular 3-layer architecture. Could you walk us through those layers? How do they function?
Certainly. It's designed logically, like many operating systems. The top layer is the interface layer.
Okay, the part we interact with.
Pretty much. This is your front door, how you, the user, or maybe another AI agent, talks to MemOS. Think of it as a smart translator and command center for memory operations.
What are the components here?
There are a few key parts. First, the mem reader. Its job is to take your natural language requests like, hey, summarize my meeting notes about Project X from last month, and intelligently parse that.
Figure out what you actually mean.
Exactly. It extracts the key entities, the time ranges, the topics, the intent, and translates it into a structured query that the memory system can understand. Then you have the memory API.
API, Application Programming Interface.
Right. This provides a standardized set of commands for interacting with the memory. Things like query, write, update, transfer. The crucial thing is every interaction, every command uses a memcube as the standard unit.
Consistency.
Total consistency. And finally, for more complex workflows, there's the memory pipeline. This lets developers or AI agents chain together multiple memory operations in a sequence. For example, retrieve relevant notes, augment them with new info, update the main memory archive, the old version. It ensures complex memory tasks happen reliably and consistently.
Okay, so that's the user-facing side, handling requests intelligently and providing standard tools. What's happening underneath that in the middle? What's the operation layer?
The operation layer is really the control center. This is the brain of MemOS where the heavy lifting of organizing and scheduling memory resources happens.
The management hub.
That's a good way to put it. A key component here is the Mem Operator. Its job is to structure the memory effectively. It uses tags, builds knowledge graphs, creates hierarchical layers, basically, making the memory searchable and organized. It supports sophisticated retrieval methods, too, like combining rule-based filtering, only show me documents from last week, with semantic similarity search, find things similar to this concept.
So it helps find the right memory efficiently.
Very efficiently. Then, arguably the most crucial part of this layer is the Mem Scheduler. This is the central dispatcher.
What is it, dispatcher?
Memory itself. It analyzes the incoming task, looks at the available system resources, considers priorities, and then makes the critical decision. What's the best type of memory to use for this specific task right now? Should it pull from plain text, use fast activation memory, or rely on the core parameter memory?
It chooses between those memory types we discussed.
Yeah. Yes, and it decides how to load that chosen memory for optimal performance. It's also the component responsible for intelligently managing that cross-type memory migration, promoting hot memory, offloading cold memory, ensuring the right information is in the right place at the right time.
Wow, that's a lot of complex, real-time decision-making happening just under the surface. And there's one more piece in this layer. Mem Life Cycle.
Yes, the Mem Life Cycle module. This component tracks and manages the state of each memory object, each mem cube, throughout its entire existence.
Like its status.
Exactly. Is this memory currently generated? Is it activated and in use? Has it been merged with other memories? Or is it archived? It manages that whole life cycle. And it even includes a really interesting feature they call a time machine.
A time machine, like go back in time.
Sort of. It allows for creating snapshots of the memory state and supports rollbacks. So if something goes wrong or you need to revisit a previous state, you can potentially restore an older version of memory. That could be invaluable for debugging complex AI behaviors or recovering lost context.
That's actually really useful. Okay, interface layer, operation layer. What's the foundation? The infrastructure layer. This sounds like the deep backbone holding everything up.
It absolutely is the foundation. This layer handles the core plumbing, storage, security, and migration of memory data.
So the nuts and bolts.
The critical nuts and bolts. You have the Mem governance module here. Think of this as the security guard for the entire memory system.
Okay, what does it guard?
It strictly enforces all those access control rules we talked about, who can see what memory. It implements the lifecycle policies like when memory should expire, and crucially, it tracks provenance.
Provenance, where it came from.
Exactly. Where did this piece of memory originate? How has it been changed over time? By whom? This is vital for trust and accountability. Mem governance can even watermark generated content that uses specific memories, adding another layer of traceability.
That's serious governance. What else is down here?
There's the Mem Vault. This is the central storage hub.
Right.
It's designed to manage potentially different memory repositories. Maybe you have private user memory, shared team memory, specialized expert memory modules. It handles interfacing with various backend storage systems like databases or vector stores.
The actual storage management.
Yes. Then, complementing that, you have the MemLoader and MemDumper. These are the essential import-export tools.
For moving memory around.
Precisely. They allow memory, packaged in those mem cubes, to move seamlessly and securely across different platforms. For example, migrating your preferences from an AI on your phone to a more powerful AI running in the cloud, or maybe to an agent on your desktop.
Break down those memory islands we talked about earlier.
Exactly. That's a key goal. And finally, perhaps the most futuristic component in this layer is the Mem Store.
Mem Store, like an app store.
Kind of. It's envisioned as an open marketplace for memory, a place where individuals, institutions, or even AI models themselves could publish, subscribe to, and distribute specific memory units or knowledge modules in a controlled way.
Wow, a marketplace for AI knowledge components.
That's the vision, sharing specialized expertise packaged as mem cubes.
So putting it all together, it really does sound like a fully integrated, almost self-aware ecosystem for AI memory. Every piece of information has a clear identity, a job, a life cycle, rules about its use. That's a massive leap from just static models with a temporary context window.
It's a fundamentally different architecture.
And the paper suggests this isn't just a theoretical blueprint, right? They actually tested it. How does MemOS perform in practice?
They did test it, yes. The paper presents some pretty impressive results on a benchmark suite called Locomo.
Locomo. What does that test?
It's specifically designed to evaluate performance on tasks requiring long context understanding and multi-hop reasoning, exactly the kinds of things current LLMs struggle with due to memory limits.
And how did MemOS do?
Across the board, MemOS consistently outperformed the existing state-of-the-art baseline systems they compared it against. Systems like LangMem, Zep, even the memory features in OpenAI models, and another called Memito.
Outperform them in what way? Accuracy.
Yes, in accuracy and task completion, especially on the really challenging multi-hop reasoning tasks and scenarios that involve tracking information over long periods.
That's a significant improvement over what's out there now. And I think I read somewhere it wasn't just smarter, but faster too. Is that right?
That's precisely right, and perhaps one of the most compelling findings. MemOS achieved this superior performance often with lower latency than even some of the simpler memory systems.
Lower latency, meaning faster response.
Faster responses, yes.
Oh.
They even demonstrated some really significant speedups using a specific technique called KV-based memory acceleration. That's a way to quickly retrieve key value pairs from the memory cache.
How much faster?
In some of their tests, they managed to reduce the time to first token, that's TTFT, basically how long it takes for the AI to start generating its response by over 90%.
90%?
Yeah.
That's huge.
It's a massive performance gain, especially for interactive applications. It means the AI can start responding almost instantly, even on complex tasks that require accessing a lot of memory, and importantly, without sacrificing the quality of the output.
So faster and smarter. That's the dream combo. Okay, beyond the benchmarks, what are some of the truly game-changing applications or maybe new architectural possibilities that a system like MemOS unlocks?
Well, the paper highlights a couple of really significant architectural innovations that MemOS could enable. One of the biggest is the concept of paid memory as modular installables. Or you could call it memory as a service.
Memory as a service, like software as a service.
Exactly the same idea.
Yeah.
This is a potentially huge paradigm shift. Imagine a domain expert, let's say, a top-tier physician carefully curating and encapsulating their diagnostic knowledge and heuristics into structured memcubes.
Okay, packaging their expertise.
Right. They could then publish this expert memory module via that memstore concept we mentioned.
And others could use it.
Yes. You, perhaps as a medical student or an AI assistant working in a clinic, could essentially install this expert knowledge module locally into your MemOS-powered system. You might even pay a small micropayment for access to this licensed intelligence.
Wow, so it's like downloading an expert brain module for your AI.
In a way, yes. It could fundamentally break down barriers to accessing highly specialized knowledge, making expertise much more distributable and accessible.
That's incredibly powerful. An app store for verified expert AI knowledge. What's the other key innovation mentioned?
The second big one is what they call painless memory management, which enables a more task-oriented paradigm.
Painless how? Meaning the user doesn't have to worry about it.
Exactly. You, the user, wouldn't need to manually manage the AI's memory at all. MemOS abstracts it away, treating it as this universal resource that the AI itself intelligently manages behind the scenes.
How would that feel in practice?
Let's take a legal assistant AI, for example. As you shift your focus within a task, maybe you start by reviewing the overall layout of a contract. Then you move to specifically highlighting potentially risky clauses.
Okay, different subtask.
Right. MemOS would dynamically automatically load and swap the precise memory sets needed for each subtask. Maybe it loads contract template memory when you're focused on structure, and then seamlessly swaps in risk clause case logs when you start looking for potential legal issues.
So the AI's brain adapts instantly to what you're doing.
Without you needing to do anything, it becomes truly memory as resource, use on demand. The complexity is handled by the system, not pushed onto the user.
That just makes the whole interaction feel much more fluid and natural, I imagine. Okay, so those are big architectural shifts. How does it translate into better everyday application scenarios for us, the users?
Well, it directly addresses those challenges we outlined earlier. First, multi-turn dialogue and cross-task continuity.
No more forgetting mid-conversation.
Hopefully. MemOS is designed to extract the salient points from your conversation, link them intelligently to the AI's long-term memory store, and ensure that context persists. It could even remember details like your ID number from when you filled out one form and automatically recall it when you start filling out a related visa application in a completely different session or even a different app.
Now, that would be useful.
It makes the AI feel much more context-aware and genuinely helpful over time.
So the AI becomes a truly persistent, understanding assistant across all your interactions with it.
That's the goal. Another key application area is knowledge evolution and continuous update.
Keeping the AI's knowledge current.
Yes, but in a much more dynamic and governed way than just relying on ARA-RAG. Imagine new medical guidelines are published. Memos could ingest them, tag them as trusted or verified, automatically compare them to older versions stored in its memory.
And flag conflicts.
Exactly, or even suggest updates to related memories or procedures. The AI stays current without needing constant, expensive retraining of the whole model. And you could even build personalized knowledge paths that evolve as you learn or as your field changes.
That really sounds like a living, breathing knowledge system within the AI. What about making it feel more personal?
That brings us squarely to personalization and multi-role modeling, because memos can store and manage fine-grained preferences and context.
It could remember how I like things.
Yes, your preferred language tone, specific details about your projects or family, and crucially, it can maintain those different roles you might interact with it in. Maybe you talk to it differently as a parent planning family activities versus as a manager drafting work emails.
And it could switch between those personas.
Dynamically load the appropriate persona, preferences, and relevant memories for each context, making the interaction feel much more tailored and appropriate.
And finally, you mentioned those memory silos earlier. Does MemOS fix that?
That's the promise of cross-platform memory migration, because memcubes are designed as standardized, transferable units.
They can move between systems.
Right. Your family travel preferences, memory, maybe built up interacting with an AI on your mobile phone, could potentially be securely migrated and made available to a corporate travel planning agent running on your desktop computer.
Ensuring consistency everywhere.
Ensuring consistent decision-making and preferences across all your different devices and AI agents. It really means your AI assistants could start to feel like they genuinely know you, remember your shared history, and adapt to your changing needs no matter where or how you're interacting with them.
That feels like a fundamental shift. Not just an incremental improvement, but a different kind of AI interaction altogether.
It really could be. We've seen how Memo attempts to tackle this fundamental challenge of AI memory, potentially moving these large language models beyond being just static text generators.
Towards becoming continuously evolving, genuinely intelligent agents.
Exactly. It introduces this unified abstraction, the memcube, which is key, along with integrated management tools and robust governance for all the different types of memory an AI might need.
And it really does shift the whole paradigm for AI, doesn't it?
Yeah.
Memory stops being just, static data baked into a model or lost in a short context window.
And becomes what?
It becomes, a first-class, dynamic, computational resource, something actively managed, evolving, and maybe even defining what the next generation of AI looks like.
I think that captures the potential impact quite well. It's a very different way to think about building intelligence.
So here's a provocative thought to leave everyone with, building on that MemStore idea. What if, in the fairly near future, you could literally buy or subscribe to highly specialized expert memory modules for your own personal AI assistant?
Like what?
Like imagine downloading a renowned legal expert's complete set of negotiation tactics, or maybe a Michelin star chef's entire repertoire of recipes and techniques, or perhaps a leading historian's full, nuanced knowledge of a specific historical era.
And just plugging it into your AI.
And seamlessly integrating it into your personal AI's evolving brain, its MemOS. The paper hints at this vision, a decentralized memory marketplace, maybe even self-evolving memblocks. If knowledge itself becomes this fluid, transferable, almost living resource, what kind of collective intelligence could we actually build then?